Hi physics, this is Mrs. Ellsworth, and I wanted to quickly just wrap up the ideas of what we did in this first part of this lab, and I wanted to do a little bit of verification of what you did and show some results because we would have presented that. And I know that you probably don't want to sit through this, so I will make it quick and I will try and make it as painless. But in this lab right here, I think this one was Micah's, he went and did the weights. Instead of having the period over here, he's got them switched around, but I think we can pretty much verify some things here. See, this graph makes it look like that it's linear and that it is a excuse me, a proportional relationship, but when you really look at this data set, these are the same. So this is showing that when he increased the weight, that he really didn't change the period at all. Okay, and that's what we expect with our formula. In this other data set right here, when you look at how he changed the length of it, it really changed the time. It really changed the period. Okay, so that was pretty cool. Here's another set of data. I was talking to a student where they changed the angle on it for each time, and that it did have a slight fluctuation in the period, but it isn't a whole lot. So the angle in this one here didn't really show much of a change, but then when you look at the graph like this, when they go and change the axis so much, this really isn't much of a variation here. It is slightly, but it isn't much. Okay, so this one here was at the angle. Okay, here's another set of data. Look at we've got the different inches here, and now this one didn't change so much. I was kind of surprised by that. This normally does change, but you got to report what you get. Okay. And so in this case right here, his data would prove that length did not matter. The length of the whole pendulum where the bob is hanging. Okay, and then this one here, he just had to weigh with his hands something that was heavy and something that wasn't, and so he got pretty close to the same amount here. And on his graph, though, when you plot 2 points and it separates them out as much as possible, it makes it look like that it was a humongous difference. But when you look at the data, the weight did not matter. In this case, neither did the length. In fact, they were all about the same. Okay, here we got another one. And this one was so interesting, and if he wouldn't have had such a good detailed video showing me what he did, I figured out that he really didn't change the length of his, because I was writing comments here saying your length really isn't that much different, and I can't figure out why this is different. But really what he was doing is he was measuring the distance from where the bob was released to where it was going for the full wavelength. Okay, so that's what that one really was measuring, and they were also catching it between, so it was kind of difficult, and so you know why that sometimes that a result would be different than the other ones. It was following a different procedure than what I had said, but it was engineered quite well when he explained it in the video. I was quite happy with that. Okay, so this one was pretty much the same thing, but it was interesting how that one was done. I did notice that from the video on that one, that it just really helped verify, and that I like doing these in the classroom so I can steer students in the right direction and make sure that everything is working right. Okay. Moving on to the next set of data. This is quite interesting. Nice data table, even though it's not your typical XY table. Okay, look at this. The different lengths, it gets smaller as we go here, and so did the excuse me, the period. And so there was that one. Now notice that is down here and then it comes up here. So I've been wondering, should these things be actually curved more like a square root graph? I mean, when you think about that formula, t equals 2 pi and then the square root of length over g. I wish I had that written on here, but I don't. It's quite interesting to think about it that way. Here's another set of data. Okay, here is released at 45 degrees, so that they were showing me, hey, we didn't have a change in variable up there, good job. And that the difference in the time really changed a lot when they had different lengths of a pendulum. And then look at this one. We have a slight change on this one too. It becomes greater as time goes. And I am wondering on these if this period needs to be over once more. I assume that it did. That was during 10 trials, and that the period needed to be over once. Anyway, so if it did, and then that means that there wasn't much of a fluctuation, but I mean, it had twice as much fluctuation as this side. So, but you still, again, you have to report what you get, and I need to remember to send out an email to this guy, gal. I can't remember who. I'll figure it out. Okay, here's another set of data. This one right here, look at the lengths. Okay, longer to shorter. It really changed the period. And then when you add the different weights, boy, I don't know how they got good weight sets, but good deal. Notice it doesn't change very much. It did change a smidge though, didn't it? It went up 20. Okay. And so, and that was a good graph of that too. Good information on that. It's still not much of a fluctuation there. And with our crude measurements, I'm thinking that that's pretty great. Length of pendulum again. Look at the different lengths here. This one doesn't have as much fluctuation on time change, but it really only went 8 inches different, but I thought that it would have more, but that's okay. This one right here is on the angle, and look at the angles here. It's got a slight fluctuation in time too. It's not too much different from this one, so that's kind of a bummer that one didn't have much of a change, but again, you've got to report what you have. Okay. And, oh, shucks, I wanted to put another one in there. Let me see if I can grab it real quick. Hold on. No, here we go. This right here is what I've been wondering about. Should this actually be a graph that is shaped like this? Because if I remember right, in math class, wasn't that a shape of a square root graph? I mean, I may be wrong there. See, this right here would be exponential, so that would be a square root. Because if you remember that formula, did have a square root in it. So I was quite interested in thinking about that quite a bit. Wait, maybe that wasn't the graph I was looking at before. Yeah, this one. Oh, sorry. This is the one I was thinking about. Yeah, I just think that this right here looks like that this one should be actually a square root shape. And I'm wondering if it should be. I'm going to actually go and look into that some more. But interesting enough, some of the labs did not go with the math, and I made comments of that you still got to report what you got. I appreciate all the effort that people did in this, and if I would have been in a classroom, I would have steered you however I wanted to steer you with it. But I think I've talked long enough here, and I hope you didn't fall asleep on this, but it's a good example of student data, and I appreciate your videos proving to me that you actually just did the pendulum, and some of you explained it so well. I really appreciated that. So thanks again for your effort. Bye-bye.